Hi, this is my second video where I will talk about, in this one, about calculating electric potential. Now, one of the things I want you to know about, and maybe we mentioned this before in all previous physics courses, for any potential energy, we should have a reference point, reference level, whatever it is we call it. And that is really where we're going to set our potential energy to be zero. All right, and remember, potential energy, it equals Q times V. Then it's like what is the reference for the potential energy is going to be the same as the reference for electric potential. Now we consider V to be zero at infinity. And that is making sense when the charge is at one point and I am calculating the potential at a very, very, very far point. That making sense that it is zero, like it does not feel okay, although maybe it's an approximation, but it's a valid one. All right. Now, in order to calculate electric potential, I will say there are main four methods. The first one, we call it electric potential of a point charge. Remember, potential energy, electric potential is a scalar quantity. Which means it does not have a direction. Now, when we did calculate, like in previous chapters, when you calculated F or E, okay, in the equations, for example, for F electric, it is K electric Q1 Q2 divided by R squared. Here, we did not substitute the sign of the charge. Then we're going to put the absolute values of the charges. And we will work on the resultant based on the directions of the vectors to find what is really the net. Now, for a single point charge here, when we are calculating V as 1 over 4 pi epsilon 0 Q over R, now that Q, it's actually the value of the charge or the point charge. And of course, it is measured in coulombs. And if the charge is negative, then I will say V is negative. And you have to substitute that in the equation. Now, for R here, it is the distance from the point charge to where the potential is measured or calculated. In electricity and magnetism, we don't work with the non-SI units. I mean, when it is centimeters, it should be converted into meters. If we have in any equation, we're gonna have the mass, it should be in kilograms. And here, of course, epsilon 0, it is the electric constant. Now, what if I have a distribution or a collection of charges, and these here are not really continuous, these are discrete. Discrete means you have maybe one charge here, another charge here, another charge here. They are not really, it's not a continuous distribution of charge. All right, here we're gonna have V as calculated as just the algebraic sum of all, like Qi over Ri. Then you're gonna say is gonna be 1 over 4 pi epsilon 0 Q1 over R1 plus Q2 over R2 plus Q3 over R3. All right, and it was really discussed this in the lecture, but just I'm summarizing here. I'm not like presenting new material. Okay, number 3 here, if the distribution is continuous, then that sigma will be integration, of course, integral. And then V here is going to be 1 over 4 pi epsilon 0 integration of dq over r. And again, here we consider V to be 0 at infinity. And of course, I presented some of the, I will say, some of these, I will say, equations and how to use them in the main lecture. Number 4, when the electric field is known, then there is another way of doing it. It is easier to calculate electric potential using electric field all right. Then here I will say, you know, this is another method of doing it. Then we have 4 methods. I'm gonna do another video just to show you how I'm gonna calculate the electric potential of a conducting sphere. Thank you.